Good morning. Today, we're looking at one of the most ambitious technological moonshots of our time, Google's Project Suncatcher. This initiative aims to fundamentally reshape the future of computing by building solar-powered AI data centers not on Earth, but in space. The vision is to deploy networks of satellites, each equipped with Google's powerful tensor processing units, or TPUs, into orbit. The core value proposition is threefold: harnessing the immense, uninterrupted power of the sun, achieving unprecedented computational scale, and launching the first prototypes by early 2027 in partnership with Planet Labs. As Google CEO Sundar Pichai announced, our TPUs are headed to space. He framed this as a natural evolution of Google's history with moonshot projects, exploring how we can one day build scalable machine learning systems beyond our atmosphere. The energy challenge. So why look to space? The answer lies in a critical challenge facing the entire tech industry: the insatiable energy demands of artificial intelligence. As AI models grow more complex, their computational hunger skyrockets, pushing terrestrial data centers to their limits in terms of power consumption, physical space, and cooling requirements. Project Suncatcher is a direct response to this bottleneck. As Travis Beals, senior director at Google, notes, if the demand for AI continues on its current trajectory, space offers tremendous potential to scale. This project isn't just about building data centers elsewhere, it's about finding a sustainable path forward for the next era of AI development, free from the energy constraints of our planet. The technical architecture of Project Suncatcher is as revolutionary as its concept. The plan involves placing satellite constellations in a specific dawn-dusk, sun-synchronous, low-Earth orbit. This strategic position allows the satellite solar panels to receive nearly continuous sunlight, generating up to 8 times more power than equivalent installations on the ground. These satellites would fly in a precise formation, just hundreds of meters apart, much closer than current constellations like Starlink, and would be connected by ultra-high-speed free space optical links, achieving a staggering 1.6 terabits per second. The economics are also becoming viable. Google's analysis projects that launch costs could plummet to around $200 per kilogram by 2035, making the cost of space-based computing comparable to building and operating terrestrial facilities. Now, venturing into space comes with a unique set of extreme engineering challenges. The first is radiation. In space, electronic components are bombarded with radiation that can degrade or destroy them. However, Google has already conducted promising tests exposing their latest trillion TPUs to radiation levels 15 times higher than the expected 5-year mission dose. As Travis Beals reported, they held up quite well, indicating surprising resilience. Other major hurdles include thermal management, dissipating massive heat in the vacuum of space without conventional cooling systems, establishing reliable high-bandwidth communication links back to Earth, and maintaining the precise formation flying required to keep the satellite cluster intact. The 2027 prototype mission is specifically designed to test these critical systems. Project timeline. Let's look at the roadmap for turning this vision into reality. Following the project's announcement, Google will spend 2025 and 2026 in an intensive phase of advanced testing and validation here on Earth. The pivotal moment comes in early 2027 with the planned launch of 2 prototype satellites in partnership with Planet Labs. This mission is a proof of concept designed to validate the core technologies in the harsh environment of space. Looking further ahead, beyond 2030, lies the goal of commercial-scale deployment. This would involve launching full constellations of these AI-equipped satellites, creating a scalable off-world computing infrastructure that could support the AI workloads of the future. Industry context. It's important to view Project Suncatcher within the broader, rapidly evolving context of the new space economy. Google is not alone in looking skyward. Companies like SpaceX with Starlink have pioneered the satellite constellation model. Elon Musk has even proposed using AI-controlled satellites for climate intervention. Meanwhile, other players like Momentous and DeFi Space are partnering to launch orbital edge computing payloads as early as 2026. And on Earth, governments are making massive investments in AI supercomputing, as seen with the U.S. Department of Energy's recent announcements. Google's entry into this field with Project Suncatcher signals a bold commitment to leading the next frontier of computing. As their analysis concludes, this approach has tremendous potential to scale, potentially creating a future where the most demanding AI computations happen not in vast server farms, but in constellations of intelligent satellites orbiting our planet. Thank you.